So molecularly, there's a few changes that happen, but mostly the molecular composition of the cadaver is pretty close to the living system. But energy flow, I think, is the defining characteristics. Energy flow, and then as energy flows through the biophysical constraints, right? This like metabolic circuitry that we call metabolism in the body, that the transformation of energy as it flows, energy as it flows through the constraints of our metabolism leads to transformation. That's the defining characteristic. So when you stop breathing, the heart stops beating, and blood flow stops in the brain, right? The flow of electrons from food to oxygen stops, and that's what we call death, right? And then the absence of a heartbeat or breathing or EEG on the brain, those are kind of footprints of energy flowing through the system. So they're kind of symptoms of the absence of energy flow. So I think that's the primary difference. And if this is a first principles definition or understanding of the the distinction between life and death, and which I think is really powerful to then ground understanding theories and then experiments on, as opposed to kind of higher level symptoms level explanations for what death is, for example.
We're going to have probably a pretty good mix of people that listen to this in terms of what they already understand about some of the biophysics here, some of the mitochondrial metabolism stuff and everything. But let's just start out pretty basic with energy flow and electron flow in mitochondria. So we've got these little things called mitochondria in all of our cells. They're often called the powerhouse of the cell. This is where a lot of the molecular energy gets made. How are they working in terms of electron flow? And can you explain that in terms of how it relates to why we breathe oxygen and why we eat food and what that has to do with the flow of electrons? Some people listening will not really know how those things connect together.
Yes, thank you for bringing that up. The best analogy, that I think you can use to understand metabolism and what the role of mitochondria in energy metabolism and flowing energy, I think, is an electrical circuit, right? And an electrical circuit is the simplest, kind of ideal electrical system. There's a battery with a negative electrode and a positive electrode. And then there's a circuit, or let's say a wire, that connects those. And then the electrons go from the negative pole to the positive pole, and the electrons flow, and that's driven by the electrical potential, right? The voltage of the battery. And then in flowing, they meet some resistance. And if you want the electrons, the electrical energy in this case, the electric field to do something, to produce work, then you need those electrons to face some resistance. And that would be a motor, for example, or something like that. So in this system, the equivalent in the human body is metabolism, is the circuitry, is like the wire with a bunch of little resistances. So every step in the of metabolism, maybe some people have seen those maps. It's like when you're zoomed out, it's like a Sigma used to have those maps with like all of the metabolites and the arrows, and there's at least like 1,000 things on this with lines that cross all over the place. Like every little step here is a resistance, right? In electrical terms. So a resistance is something that slows down or opposes the flow of something, right? For like the fundamental definition of a resistance, the way I understand it. So food, in this case, because you can say, okay, metabolism and this, biochemical thing that we call the body and the metabolism that's in our cells is like the wiring and the resistances. What's the negative pole? Where do the electrons come from in the body?